Wow, these are some big questions here. So, what do climate scientists do? What are the most important factors we need to understand in order to model and project climate change into the future? How do we go about doing that? What tools do we use? What do we need to understand? Well, so what do we do? Climate scientists have lots of different roles, and there are lots of different people doing those roles. There are people who observe the current climate. They go out, they actually measure the world, they measure temperature, they met in the air, in the ocean, at all different levels. They use lots of different tools to do that, and it's a very, very difficult job to do properly. That's why it's done by experts such as those at the Bureau of Meteorology and those at CSIRO. So that observational step's really important. Then we have physicists who understand how the physical world works, and they take the observations, they look at the patterns they can see in that, and they create equations that describe how energy and matter move around the planet. And those equations are then they're designed using the observations so that they reflect what the observations tell us, and then they're put into big simulations, big four-dimensional models that have hundreds of equations in them, and those equations then have to be balanced so that the model can create a simulated world. So it's kind of like if you're in playing Roblox or Minecraft. That world kind of looks like the real world, but it's different. It's blocky. It's different, and that's kind of what our simulations are like. Now, the less blocky we can make the simulations, the more accurately they describe how the climate works. The thing that's absolutely amazing about these simulations that we use is that given that they're just a bunch of equations that we're working with, they do an amazing job of simulating, representing what actually happens on Earth. And they just look incredible when you see them moving. So we use those climate models. Once you've got a simulation, you can then take that simulation of Earth, and you can do things like switch off the sun and see how long it takes for the whole Earth to freeze over. You can do things like double the number of volcanoes that happen, or change the position of where those volcanoes happen around the world and see how that impacts on climate. You can change the position of the continents and see how that changes the way ocean currents move, and be able to understand these different stages that the planet might have been in back in when the dinosaurs were around, and what did the climate look like. And the other thing you can do is you can change the concentration of carbon dioxide in the atmosphere and test whether that's the thing that's most important for long-term climatic change. And that's what we've found, is that the changing the concentration of carbon dioxide in the atmosphere has a very important impact on how the climate works. And that's why we're able to, by doing thousands of runs of these simulations and lots of different tests, by testing lots of different compositions of the atmosphere, we can prove that it's actually carbon that's one of the most important things for long-term climatic change. And that's why we have to stop burning it and putting it into our atmosphere. Thanks very much to Reese High School Grade 8, Lambert High School Grade 9-10 Science, and Farn School Grade 6H, and Riverside High School Grades 8, 9 and 10. It's a really great question.